Welcome back to the classroom. My name is Mr. Wong. Today we're going to go through Module 1, Inquiry Question 2, Exam Explain question. This will be the 2019 PEM Physics question 24. We have a man that can travel at 6 meters per second in still water, tied to a jetty south of the bank of a west flowing river. So we have a river that's flowing in the west direction, and that is 1.5 meters per second. Keep that in mind. If, assuming that the boat was going through a non-moving river, so there's no water going through, you can assume that the boat is going at 6 meters per second along set that way. So if we're dealing with the water is still, so it means in the perspective of the water, the river is also flowing at 6 meters per second. So from what the river can see, the water is sort of coming along in front of it at 6 meters per second, like so. What that means is the relative velocity of the boat going across the river will be the square root of 1.5 squared plus 6 squared. In this case, that'll be 6.81 meters per second, approximate. Now, obviously I haven't quite finished the question, so let's just go over what the question's asking. They cross a river that is 56 meters wide. The beach that the boat driver is trying to get to is 40 meters upstream from the direct opposite of the jetty. So the jetty's over here. If the river's flowing west, then upstream is the opposite direction, which means upstream here, the beach is here. Okay? So the overall distance that needs to be traveled by this boat driver would have to be the square root of 40 plus the square of 56. Square of 40, sorry. Square of 40 plus square of 56, and then the square root of that. So the answer to that would be 68.81 and so on. And just the minor correction with this value here, it's 6.18 meters per second. We have our meters here. We can round it off to 3 sig figs if we want to. It's not too big a deal. Okay, so from here we can actually, so now that we know the distance and we know the relative velocity the boat has to travel, the reason why we're saying, the reason for this is because we know the boat will have to travel 6.18 meters per second in this direction. That will account for the river pushing it to the west in that particular direction, so you should see it come directly to the beach in a straight line across like so. Okay, so we have the velocity, we have the displacement. Now it's time to work out what the overall time it's taken will be. In that case, the velocity or the displacement is 68.8 divided by 6.18, so approximately again we get 11.11 seconds. So that's how long it's going to take our jetty or boat driver to go to the beach over here. Next part of the question is, in which direction should the man set off across the river? So, well, we know for sure that as the beach is over here and the river is flowing across like so, to go directly along we need to go in this direction. So it's going to be north west direction along this particular stretch. Okay, so this is the angle we're looking for. Now we could use the velocities, but a more simpler way of working it out is the distances. So we know the distance to travel north is 56 meters. We also know the diagonal strip that we need to move is 68.8 meters. So let's try and work out the angle using these components, or you can also work it out by the distance in how far the beach is away from us. So let's do that. So tan theta, or theta is tan 1 inverse 1, 40 over 56. And the angle we get approximately is 35.5 degrees. That means we need to travel north 35.5 degrees west in order to reach the beach in a straight line. So hopefully that explains to you how to cover this question on relative velocity in the river system. This might be slightly different from what the initial answer was, but based on the criteria that we've been given, this is the explanation most appropriate to it. Thank you for listening, and I'll see you again next time.